So today we pay special attention to momentum and impulse. So let's consider this situation. It says ball P of mass 0.16 kg moving east at a speed of 10 meters per second collides head-on with another ball Q of mass 0.2 kg moving west at a speed of 15 meters per second. After the collision, ball P moves to the west at a speed of 5 meters per second, as shown in this nice diagram below. Ignore the effects of friction and the rotational effects of the balls. So if we ask you to ignore friction, we are actually telling you that this is an isolated system. Fine. The first question says, define the term momentum. Well, you can do that. The next one says, calculate the velocity of the ball Q after the collision. And I want you to realize the question said velocity, not the magnitude of velocity. So we want the vector nature of velocity, both magnitude and direction. And furthermore, we have to realize that the two balls are separate before the collision. Even after the collision, they still move separately. It's very important. So the easiest way for us to find the velocity is to use the principle of conservation of linear momentum, since this is an isolated system. So let's go to the whiteboard for that. Now, what does this principle say? It says the total linear momentum in an isolated system before the collision is equal to the total linear momentum after the collision. This is what we are saying. Now we go for ball P. So we know that the momentum of ball P, it's the mass of ball P times the initial velocity of ball P. Then you say plus, we go to ball Q, so it's the mass of Q times the initial velocity of Q. And this is equal to the mass of P times the final velocity of ball P. Then you say plus the mass of ball Q times the final velocity of ball Q. So for this one, you can just say VQ if you like, but it's nice if you say VQF. It's fine. Now, let's decide on direction. So we choose to say anything that goes to the east is positive, meaning west is negative as a result. Fine. The mass of ball P, it's 0.16 kg. The velocity is 10 meters per second. The mass of ball Q, it's 0.2 kg. Its initial velocity is negative 15 meters per second. Fine. The mass of P is still 0.16. The velocity final, it's going to be negative 5. And then you say the mass of this one is still 0.2, but then we are looking for the final velocity of ball Q. Now, how do we take care of this mathematics? So this is actually one term. So we transpose it to the left so that it becomes positive. So what am I going to type in my calculator? I say 0.16 times 10 minus 0.2 times 15 plus 0.16 times 5. So then I get negative 0.6. Then I say this is equal to 0.2 times the final velocity of Q. Then from this point, I divide both sides by 0.2. So this means VQF, it's just going to be -3 meters per second. But you can't leave your answer as negative. So you have to conclude and say, therefore, the final velocity of ball Q will just be 3 meters per second to the west. And you should be happy after saying that. So what does the next question say? It says, calculate the magnitude of the impulse on ball P during the collision. So by definition, we know that impulse, it's the product of the net force acting on an object and the time taken for the net force to act. But we understand, according to the impulse momentum theorem, the impulse is equal to the change in momentum. So if you look at your statement, you can see you're not given the net force nor the time. So it means the best you can do in finding the impulse is to calculate the change in momentum of ball P. That's the best you can do. So we know that change in momentum is actually mass times the change in velocity. So we say the mass of ball P is 0.16 times what? The final velocity of ball P is -5, but its initial velocity, it's negative. In fact, it's +10. So if you say 0.16 times -5 minus 10, you just get -2.4. Now the question is, what is the unit for impulse? It's okay if you say kilograms meters per second, which is the unit for momentum, but the official unit for impulse, it's Newton second. So it's always nice if you give it its unit, Newton second. But once again, you can't leave your answer as negative. So you have to say it's -2.4 Newton second. That is the magnitude of your impulse. Yes, I hope you are not lost here, because this is change in velocity, final velocity minus initial velocity, and then you should be fine.